Hello everyone, and welcome to the first lecture for your statistics course this semester. In this course, we will be covering a number of descriptive statistical methods and techniques. We will have an introduction to inferential statistics, where we would look at some estimation and a bit of hypothesis testing, but the second semester is dedicated to the more inferential techniques. And so I know that for most persons, this is their first course in statistics, and that's fine. That's fine because this is an introductory course, and so we will go through all of the techniques that you need to know in order to be successful. And so in this initial lecture, really, I just want to cover some of the terms that will be used throughout the course. And it's very important for you as you go through this lecture to take notes. I know you have access to the slides, but it's really helpful for you to take some notes of these key terms because you're going to hear them quite often. And it's going to be important for you to be able to put them into context and not necessarily associate them with their everyday use. And so the vocabulary is what is important. Now, starting with the word statistics in itself. Now, what are some of the things that come to mind when you hear the word statistics? You hear it on the news, you see it in papers that you read for school, you see it in the news, you see it, you hear it often. Often it's used in very different contexts in everyday language, but in statistics, in this course, in academia, when we use the term statistics, we're talking about, first of all, methods and processes that are used for collecting, organizing, summarizing, and analyzing data. And it is this first sort of point that we will spend most of our time in this course focusing on: the collecting, analyzing, and summarizing data. That's really where descriptive statistics is concerned. And then we move on to the analysis. Now, as I mentioned, there's an inferential branch of statistics that is focused on making inferences about a body of data when only part of that data is observed, and that is concerned with using sample data to make inferences about a population. Now, most importantly, after we've done the collecting, organizing, summarizing, we've made our inferences, it's interpreting and communicating the results of these to persons who were not involved in the data collection, the data processing, the data analysis. As it's being able to make sense of what we have calculated, what we have collected, what we've analyzed, and communicate that to a non-technical audience who needs the data. And so we use a lot of this data for making generalizations, but most importantly, and as you will see in this course as well, the data is also used for the purpose of making decisions at the policy level, at the business level, at the individual level. Data can be used for making a number of decisions. Now, there are two branches of statistics. And the one we are most concerned with in this course would be applied statistics. Now, our colleagues over in the natural sciences, they are concerned mostly with the theoretical, or what we call mathematical statistics. That is where they develop, derive, and prove all the theories, formulas, rules, and laws that we then apply to real-world situations. And so in this course, we're concerned with social statistics. So using it, applying it to address a number of the social issues that we're concerned with. So most of the persons taking this course would be social work and sociology majors, and so that's our primary focus. Our friends in economics, business management, those other disciplines would be applying the very rules, theories, formulas, and so on to very different sets of situations. So just to go back here, numbers that result from measurements, those are what we call continuous data, because that data, those numbers can take on really any value between between a given range, whereas data, numbers that result from a process of counting, that is what we refer to as discrete data. And that is because those numbers are usually finite and countable, and they're all whole numbers. Whereas continuous data, they can take on any value, meaning any decimal value between two given points. Sources of data. Now, there are a number of sources from which we can gather data. You can gather data for your research, and these include some of the ones you see on the slide here. Records that are kept at organization. We generate a lot of data in our everyday activities, most of it we don't actually use, but if you go to organizational records, a lot of times you find that you don't necessarily need to do a survey. The data already exists. So that's one source, but where necessary, we still do surveys, we can do experiments, we can look at external records. Those are data that is already published by World Bank, IMF, IDB, one of those other sources, or one of the ministries, the central bank, those places that are required to publish data in a systematic way. Those are considered external sources. Now, I mentioned the term descriptive statistics before, and this is where like I said, we focus most of our attention in this course. And in this course, in this particular context, descriptive statistics really looks at the processes for collecting, summarizing, organizing data. Whereas when we talk about making inferences from that data, we're talking about a different branch of statistics. Now, continuing from our definition of data earlier, when we, let's say for example, we do a survey, the survey that I sent out to you to complete at the beginning of this course, take that as an example. Now, all of the responses that have been collected would form what we call the data set. So when we refer to the data set, we're talking about all of that entire set of responses, or in this, as the example on the slide, if we have information on test scores of students enrolled in a course, all of the possible scores of those students would form our data set. Now, there are two things that we need to distinguish between, and those are our elements and our observations. So the element refer to the person from whom, or the source from which the data or the number is coming from. And so each student in the class, that would be an element in our data set, and the score of each student, that would be an observation. So that value, the score, that is the observation, whereas the source of that score would be the element. That's one element in your set. Now, in its original form, a data set is usually very, very large, and it's usually not very useful in that format. And so you usually have to do a number of things to it in order to get to a point where we can use it for some sort of decision making, or to communicate some result to an external person. Now, we usually have to break that down, and so we need to do things like summary tables and diagrams in order to make that easier to communicate. And so we reduce the data to manageable size by doing things like I said, tables, we do graphs, we calculate numbers such as averages and so on, standard deviations and so on, to say something about the data without having to have all of the data, without having to present all of the data, because it just would not make sense to most persons. And so this entire process of breaking that data down from its original raw form to a format where it can be easily communicated to another person, all of the steps and processes involved there is what we refer to as descriptive statistics. Now, on the other hand, inferential statistics, this is where, as I alluded to earlier, this is where we take a sample of a data set, and we use that to sample not of a data set but of a population, of values, and we use that sample to draw some conclusions or make some inferences about the wider population. Now, a major part of what we do in statistics is making decisions, making inferences, making predictions, forecasts about populations based on results obtained from a sample, because a number of times we just do not have either the time or the resources, or we just don't have access. We don't know the entire population. We don't have access to the entire population. We don't have the time to collect data from the entire population or the resources to do so. And so we satisfy ourselves with using a sample, collecting a sample, and of course there's strict rules for how this sample is to be collected, and the minimum size that is acceptable for us to be able to make such inferences. It's not any sample of values or elements that we can pull and decide to make inferences from that. No, there are strict rules that need to be followed, and we will discuss some of them. And so, for example, we may want to find the starting salary of a typical college graduate, including yourself. And to do so, we may select 2,000 recent graduates, find their starting salaries, and make a decision based on this information. And that would be a very, very simple example of the application of inferential statistics. And it's also referred to as inductive statistics or inductive reasoning. And so you'll find that to get the most out of this course, the sort of reasoning and logic, that is those are the skills that are mainly tested, and this course actually helps you to develop. So like I said, we try to make inferences from samples to populations, and looking at things like the likelihood of an event occurring and so on. You would be familiar with concepts of probability from various forms of card playing, gambling, betting, casino, that sort of thing. But we look at the formal rules and techniques of probability as we go through the course. Now, another term that you will hear very, very often in this course is variable. And a variable is simply a characteristic or an attribute that can assume different values. And so, for instance, if we are interested, the example we looked at earlier, we're interested in starting salaries of recent graduates, university graduates, that would be our variable. Every value we collect from a different graduate, that's gonna give us, it's gonna take on different values as we interview different persons and they give us their salaries. That's gonna keep taking on different values. Of course, some of it will be the same, but the point is that everyone we talk to will likely have a different starting salary. And so the variable is a characteristic. It can be a salary, it can be a temperature, it can be a height, it can be a weight, any of those things. As long as it's an attribute of our population that can take on different values, it is what we refer to as a variable. Now, the data are those values that the variables can assume. So that can be a time, it can be a date, etc. It can be a height, it can be a measure, it can be a whole number, it can be a fractional number. The data is what gives us that, but the variable is the characteristic or the attribute. The data is what tells us what the value is. Now you're gonna hear a lot about random variables. And these are variables whose values are determined by chance, meaning that we have the value that we get from it entirely depends on the person that we, or the element of our population that we collect the data from. So if we're sticking with salaries, every time we approach a different person, we don't know what value they're going to give us for their starting salary is entirely dependent on who we talk to. And so those values are random because one, our sample is randomly selected, and the value that the variable takes on entirely depends on who you talk to. You can't predict that the next person you talk to will say X or Y, or will give you X or Y value. It is not predictable, it is random. Now, we went through this earlier. Collection of data values forms a data set, and each value in the data set is called a data value, or you may see the term datum, but not very often. Now, let's look at an example, and it says here, a study conducted at Manatee Community College revealed that students who attend class 95 to 100% of the time usually received an A in the class. Students who attended 80 to 90% of the time usually received a B or a C. Students who attended the class less than 80% of the time usually received a D or an F, or eventually withdrew from the class. Now, based on the information, we can see that attendance and grades are somehow related. Specifically, we can see that the more often a student attends the class, the more likely it is that they will receive a higher grade. And so, the inference that can be drawn from that is that if you improve your attendance, your grades will probably improve. And I say probably because there are a number of other factors that will account for your grade, attendance being just one of them. Attendance is important, but it obviously would not tell the entire story. But it is one factor that you have the most control over, whether or not you will attend class. And given that most of the classes are now virtual, again, the onus is even more on you to ensure your attendance is frequent. And this is for you to do on your own time. Now, I mentioned earlier two types of numbers. Numbers that you collect by way of counting and numbers that you collect by way of measuring. And so two terms that I use to describe those two sets of data are numbers. The first is discrete, and we did mention the term discrete numbers or discrete variables. Now, these are variables whose values are countable. Now, these are values that can be finite, and they're countable, and they only take on whole numbers. So for example, we can count the number of cars owned by a family, but we cannot count the height of a family member because height is a value that we get from our process of measuring. And in measuring, you rarely get a wrong number. You can't count it. You have to measure it first of all. And in measuring, you rarely ever get a flat value. It's always going to be a fractional value. And so we can count the number of cars, we can count the number of people in a family, we can count the number of devices, electronic devices owned by a family. But things like height and weight, you cannot count, you have to measure. And so variable that assumes countable values, that's what we refer to as discrete variables. And there are no possible intermediate values between these consecutive values of a discrete variable, meaning that you will only get a whole number. You will not get 1.5 family member. You will not get 1.5 cars. You will not get 1.5 devices. It's either 1 or 2. If something is not working, it's not counting. And so it's a whole number, it's a wrong number, it's countable values. You get the numbers for your discrete variables by a process of counting earlier. Those values, those variables can take on any value within a given range. And so they are there, you have to measure to get them, and they can take on any value within a given range. Now, we also need to distinguish between qualitative variables and quantitative variables. And again, these are two terms that you may have heard before, you may have encountered before. And so qualitative variables are also what we refer to as categorical variables, because they can be placed into distinct categories according to some characteristic or attribute. And so, for example, every questionnaire that we design, we tend to ask about gender. And of course, today gender takes on a lot more categories than the traditional ones. Gender is qualitative because it can be put into categories. Religion, ethnicity, those are other variables that are qualitative in their nature, because there's no value to be assigned or no quantitative value to be assigned to a specific gender or to a specific religion. We will do that for the purpose of coding our questionnaires in order to make the analysis easier later on, but those values have no meaning. It's really just a representation of the different categories. Now, quantitative variables, on the other hand, are numerical variables. They're numerical in nature. They have numbers. And so age is a numerical value, height, weight, temperatures, all of those things are quantitative variables. And even within quantitative variables, you have the distinction of those discrete numbers and those continuous numbers. And so, as I like to say, all data is not the same, all numbers are not the same. They're not to be treated the same way. And as we will see as we go on, there are different rules depending on the type of data that you have. Now, this is very important. Most students forget this by the end of the course, but it comes back. It comes back, and so you need to keep it somewhere in the back of your head as we go on. So, scales of measurement. Now, we have nominal values, or what we call nominal measurement. Now, our categorical data that we just mentioned, a lot of times on your questionnaire, you're going to code your responses in order that when you put it into your software, whether you're using Excel, SPSS, Stata, those software will only accept numbers, and so you will code your responses. But those codes really are only representative of a category. Most of us like sports, and so we could recognize our favorite athlete by the number on their jersey. That's another example of a nominal value. The number itself doesn't mean anything. The number is just there to represent a person or a category or a thing. Your student's ID number, that number in itself is meaningless. It just represents you as the student. And so nominal values are values that in themselves really do not mean anything. They're just a representation of something else. Ordinal values, on the other hand, or an ordinal scale of measurement, represents numbers that can be ordered or ranked. And so you have a competition, number 1 through to number 10. That's the order in which people place. And so scales of measurement are numbers that can be ranked, for which there's a rank that represents ordinal. So for example, whereas if you take basketball for instance, whereas the number on the back of the shirts of the players are nominal, when you're looking at the rankings, you look at the Eastern Conference, the Western Conference, you want to know which are the top 8 teams that are gonna make the playoffs. I think that's how it works. Yes. So you want to know the teams that are gonna make the playoffs. You're gonna look at the rank, where they fall. You're gonna look at the stats and so on to see, how many games they've won, how many games behind, and so on. So those are more ordinal values. Now, interval and ratio scales of measurement are pretty similar. The thing that separates them is the presence or the absence of an absolute zero. So interval data this is a scale that represents quantity and has equal units, but 0 represents just an additional point of measurement. And so for instance, so this means that the scale does not stop at 0. It's possible to go below 0. So look at temperature, for instance, and it's possible to have a negative temperature. It just means that 0 is just a point on the scale, and going below 0 is achievable, or it's possible. It's not an impossible outcome. So for instance, if you're looking at profit as well, 0 profit means the firm is just breaking even, but negative profit would represent a loss. And so when the temperature drops below 0, we know that it's about to get very, very cold. When the temperature goes above 0, the farther above 0, then it's very hot. Below 0, it's very cold. And so it's a scale that has both positive and negative values. That's your interval scale, as opposed to your ratio scale. On the ratio scale, there's an absolute 0, meaning that numbers below 0 do not exist. And so you look at age, for instance, can't have a agent below 0, can't have a height, can't have a weight, can't have a length that is below 0, can't have a volume that is below 0. And so those scales of measurement, those types of values for which there is an absolute value, that's your scale. Now, another exercise for you to do: identify the following as either quantitative or qualitative. Now you have a number of examples there. 30 high temperature readings for the last 30 days, scores of 40 students on an English test, blood types of 120 teachers in a middle school, the last 4 digits of social security numbers for all students in the class, and the numbers on the jerseys of 53 football players on a team. And so you're going to do that and let me know. Well, you're going to do them for your purposes and see whether all of these can fit a category, can fit into either quantitative or qualitative type of measurement, or if not, how would you classify that data? How would you classify that data set? What would you classify it as? What type of data would you classify it as based on the foregoing discussion? Now you have another set of exercises to do, and so I would expect that everybody is going to attempt these at some point and have a discussion, and let's have a discussion about them.